We will be talking about direct proportion. We have to take note that when we are dealing with problems involving direct proportion, if one of the factors increases, the other one also increases. And if one is decreasing, automatically the other factor also decreases. So let's have some examples of problems which actually involves direct proportion. So we have this problem. I need 12 pieces of fruits to make 3 glasses of juice. How many pieces of fruits do I need to make 10 glasses of juice? So this is a problem that actually involves direct proportion. Looking into this, if we have 12 pieces, so the first thing that we have to take note is how can we possibly find for the statement or the relationship of the number of fruits to the number of glasses of juice that's being made. So for here, for this problem, we have 12 pieces of fruits is to 3 glasses of juice. So the relationship now is 12 is to 3. You can have this in column form or sometimes do it in fraction. So 12 is 2 or over 3. And the next thing is to equate that to the number of pieces of fruits to make 10 glasses of juice. So we have to remember that the first entry that we wrote here is the number of fruits. So let's have fruits is to the number of glasses. That simply means that in creating now the equivalent of this ratio, there we have how many fruits. So this will serve now as our variable. So this variable could be expressed by a certain x. And of course, there are 10 glasses of juice. So we will now take that as x is to 10. Again, that's one thing that we have to remember. The number of fruits is to the number of glasses. So that should also be the same in the statement that we will be having for us to have the proportion. We can now solve this by simply having the means and extremes. So again, the means must have the same product with the extremes. That is how we deal with direct proportion. Anyway, we can do that also with our fraction. So 12 over 3 is equivalent to x, which is now the number of fruits, which is actually our problem. And that will be over the 10, which is the number of glasses. Okay, so let's go back to this. So 12 is to 3 is equivalent to x is to 10. So this 3 and x refers to the means, while 12 and the 10 refers to our extremes. So the operation that is involved here is multiplication. We have to multiply now 3 with the x. So let's remember the GF here, which is the number of glasses, and the number of fruits must have the same product. Okay? The GF must be equivalent to the GF. Which simply means that if we are going to do it here, 3x is equivalent, or 3 times x is simply equal to 3x. And that is equal now to 12 times 10. And that is equal to 120. Now, ask yourself, what will you multiply by 3 to get 120? Okay, again, we are actually looking for a number that when we multiply by 3, the answer is equivalent to 120. So we can do that by making use of our division property of equality. We divide this by 3. And since we divided this left side of the equation by 3, you have to do the same on the right side of your equation. So we have to divide this also by 3. So the canceling now 3 over 3, we simply have x which remains here, and getting or giving us the answer, which is 120 all over 3 is simply equal to 40. So again, this pertains, or this x pertains to the number of fruits that is actually required if your aim is to make 10 glasses of juice. So therefore, we have 40 fruits. Now, what if, for example, we are making use this process, which is the fraction? So it's still the same. It's just that we do the cross multiplication. So the 12 and the 10 will be together, while the 3 and x will be together. So multiplying 3 and x, the answer is equivalent to simply 3x, and 12 times 10 is equivalent to 120. So as you notice, you also have, or you will also arrive at this statement. So 3x is equal to 120, and of course, the x is still equivalent to 40. And then we only have to write now the unit of measure. So 40 fruits. That is for the first problem that could actually involve direct proportion. Now, there are other cases wherein you could also use the direct proportion, but in this case, there are actually three variables which are included. So we have here the problem. The ratio of Asha's weight to Belle's weight is 4 is to 3. The ratio of Belle's weight to Shell's weight is 4 is to 7. The question is, what is the ratio of Asha's weight to Belle's weight to Shell's weight? So if you are going to look into this, there are three things or three variables which are included. It is Asha, okay, and then the other one is Belle, and of course, Shell. So these are the three people now who are actually involved. So the ratio is given 4 is to 3. Now, you have to take note that Asha was mentioned first and then Belle was mentioned second. Therefore, this 4 correspond to the weight of Asha, while the 3 corresponds to Belle's. So 4 is to 3. Okay, and then for the second statement, the 4 is to 7 is actually the ratio of Belle's weight to Shell's weight. Therefore, okay, it will just be proper that this now, the ratio of B to C will be 4 is to 7. Okay, so this problem would mean that there is this factor B. It's actually now Belle's weight that has to be manipulated. Okay? In what sense? We need to make this equal. Okay? So that we can simply compare the ratio of Asha to Belle's and of course to Shell's. So what are we going to do? We have to make this Belle's ratio equal. Okay? Belle's weight. So what are we going to do there? All we have to do is to look for a number that will actually make them equivalent. So we need to multiply now both these two, okay, so that Belle's will be the same. So since 3 and 4 are relatively prime, we don't see any factor common to them except 1. All we have to do is to multiply them by, okay, we will multiply here the 3 with 4, while this with 3. So again, if they are relatively prime, all we have to do is to exchange these numbers. So what are we going to have here now? Now, we have, let's multiply it one by one. So 4 times 4, that will be 16. And 4 times 3 is equivalent to 12. Okay, our aim now is that Bell's ratio, okay, will be the same. So still 3 times 4 is equal to 12, and that is 4 or 3 times 7 is equivalent to 21. So there you have 21. This means that you can already have Asha's 2 bells and 2 shells. So 16 is to 12 is to 21. Now, there is no way we can get the lowest term of 16, 12, and 21 for the reason that they are not divisible by a common number. Therefore, the answer to this question is simply 16 is to 12 is to 21. This is one application also of your direct proportion.